This video is for Algebra Section 11.3, Radical Equations. Our learning goal for this lesson, the learner will apply knowledge of radical equations to solve them. So the first two sections in this chapter, we've worked on simplifying expressions. Now you'll be using that to solve equations. Radical equations is our first vocabulary term. Equations containing radicals. In other words, they have square roots with variables in the radicand, so they have variables underneath those square root signs. Extraneous solutions are going to be solutions that don't work in the original equation. When you solve these, you will sometimes get a solution for the equation, but if you plug it back in, it doesn't work. Those are extraneous solutions. Prerequisite skills, you need to know how to square things, and you need to know how to solve equations. Homework will be 11.3 practice worksheet evens, and our basic algorithm that we are going to follow. First thing you'll need to do, isolate the radical. Get the square root by itself. So do that the same way you would normally solve an equation, get it by itself, the same way you would get x by itself. Square both sides of the equation, that will get rid of the square root. Solve the equation, so the basic solving equations that you should already know. And then check your answer to make sure there are no extraneous solutions. You do have to do the check because sometimes there will be answers that don't work. Alright, so for this section we are going to do every other odd on the study guide. So we'll start with number 1. Square root of a equals 8. Radical is already isolated, right? We've already done the first step. It is by itself. So square both sides of the equation. So I'm going to put some parentheses around this, square it, and square that. The square root of a squared is going to be a. 8 squared is 64. And that's it. Okay, and you could plug it back in and make sure that it works. So square root, oh sorry, not square, yeah, square root of 64 is equal to 8. Is that true? Square root of 64 is 8. 8 does equal 8, so it checks. Okay, I'm going to skip to number 5. Square root of negative a equals 6. It's already by itself, so we've already done step 1. Square both sides, so put this in parentheses, square it. And you could put parentheses here, you don't really have to though. Square root of negative a squared is going to give me negative a. Because the square root and the square just cancel each other out. You get whatever's left underneath. 6 squared is 36. I've got negative a, but I want to know positive a, so multiply it by negative 1 on both sides to solve my equation. Get positive a equals negative 36. Last step, check for extraneous solutions. So plug the negative 36 back in. Square root of negative 36 equals 6. Negative negatives just means positive, so square root of 36, that's 6. It does equal 6, so it checks. Okay, skip to number 9. Square root of x minus 4 equals 6. Again, in this case, my square root's already isolated. It's already by itself. And pretty much you should realize most of the first page is already done like that. So again, I'm going to put parentheses and square it. When I square this, the square root and the square cancel each other. I just get the x minus 4. 6 squared is 36. Solve my equation, so add 4 to both sides. X is 40. Plug it back in to make sure it works. Square root of 40 minus 4 equals 6. 40 minus 4 is 36. Square root of 36 is 6, so 6 does equal 6. My answer works. Alright, I'm going to go ahead and go to a new page. Number 13. Square root of 3r plus 2 equals 2 square root of 3. Keep in mind when it says isolate isolate the radical, we're only talking about the one that has the square root in it. Or sorry, we're only talking about the one that has the variable in it. The r is in here. So this is over here, so it doesn't look like it's isolated, but it really is. You've got a square root with an r over here. This square root's going to automatically go away too, so it is isolated. You can go ahead and square both sides. Oops, sorry, the parentheses got off. When I square this, the square root and square cancel. I get 3r plus 2. When I square this, I square the 2 and I get 4. Square the square root of 3 and I get 3. So I essentially have 3r plus 2 equals 12. Solve that basic equation by subtracting 2. Divide by 3. R comes out to 10 thirds or 3 1/3 if you want to do it that way. You do still have to plug this back in and make sure that it works. Square root of 3 times the 10 over 3, because that's where the r was, equals 2 square root of 3. Well, these are going to cancel each other. I'm going to get 10 plus 2. Well, that's 12. And going back to those skills you learned in 11.1, you need to be able to break this down. Circle your pairs, underline your leftover, that's 2 with a 3 still inside. So they do come out the same, so your answer works. And number 17. Square root of x over 3 plus 6 equals 8. And this is the first one that you've had that the radical is not isolated. So that first step is not done for us this time. So how do I get this radical by itself? Well, I want to get rid of what else is on that side. Only other thing on this side is the plus 6. I can get rid of that by subtracting 6. So square root of x over 3 equals 2. Radical is isolated, so I can go ahead and square both sides. When I square this, you're going to just get x over 3 because the square root and square cancel each other. 2 squared is 4. Solve the equation by getting x by itself, so times 3. X equals 12. Go back and check that my answer worked in the original equation, so 12 over 3 plus 6 equals 8. 12 over 3 is 4. Square root of 4 is 2. Make sure you show all of these steps. 8 does equal 8, so my answer checks. Okay, so there's a lot of steps. You need to show all of your work to make this, okay, so that you can do the harder problems too. All right, that was the first page. And you should have noticed we didn't have any extraneous solutions on that first page. So everything worked. That's good. Second page, starting on number 1. Square root of a equals a. Alright, and the difference on this page is going to be I have variables in more than one place. So that's where you're going to come up with some extraneous solutions too. Alright, well I have square root of a equals a. Well, the radical is by itself, so I can go ahead and square both sides. That gives me a equals a squared. And you do need to remember when you have these kind of equations, you have a squared and you have a number, you got to get everything on one side. So I'm going to subtract this a from both sides. So those will cancel, and I'm going to switch side. Well, I can leave them. Sorry. So 0 equals a squared minus a. Remember that you need to do this because in that other chapter where we did these, you should remember if there's a squared, I'm going to come up with 2 answers. So you'll need to factor those. So I can take an a out of both of these. I will be left with a minus 1. So if you, again, remember from the other chapters, if these are multiplied and you get 0, that means one of these two things is 0. So either a equals 0 or a minus 1 equals 0. So I would have to solve this one. So a is either 0 or 1. You have to check both of those answers to make sure that they work. So if I put it in here, I'm going to say square root of 0 equals 0. Well, 0 times 0 is 0, so yeah, that works. Alright, and if I try the second one, if I put in 1, square root of 1 equals 1 squared. Oops, sorry, 0 squared was here. Square root of 1 would be 1, and 1 squared would be 1. So both of those answers work. That is possible. You can have both of them work. Number 5. We have the square root of negative a equals a. Again, my radical is already by itself, so I can go ahead and square it. And I will get negative a equals a squared. Same process as the last one. If you have an a squared and you have an a, you've got to factor them, which means they need to be on the same side. So I'm going to go ahead and add the a. 0 equals a squared plus a. factor the a out of both of those. So this time, again, either one of those two things has to be 0 if you multiply them and get 0. So a equals 0, or a plus 1 equals 0. Oops. Subtract 1. A equals negative 1. So it's either 0 or negative 1. And sorry, I should have probably circled my answers back here so you knew where they were. And I'm going to check both these answers by plugging them back in. So square root of negative 0 equals 0 squared. You can't take a square root of negative 0. That's impossible. You can't have a negative 0, first of all. So basically this negative 0 is just 0. Negative 0 and 0 are the same thing. So square root of 0 would be 0. 0 squared would be 0. That works. Plug in negative 1. Square root of negative 1 equals negative 1 squared. Negative negative becomes positive, so square root of 1. Negative 1 times negative 1 is 1. 1 equals 1. So again, that works. I'm going to go ahead and clear the page, go on to number 9. Square root of x plus 2 equals x. My radical is already isolated, so I can square it. So I'm going to get back x plus 2 equals x squared. Again, when you have a square and an x, everything needs to be on the same side. So I'm going to subtract my x and subtract my 2. Get 0 equals x squared minus x minus 2. When you've got 3 terms like this, you should know that is when you're going to have to factor into the 2 sets, because there's nothing you can take out of all of them. But you should be able to figure out what it would be if you did this. Obviously, the first one's going to be x. Then you need to know what can I multiply together to get negative 2 and add to get negative 1. I would say negative 2, positive 1, because negative 2 times 1 is negative 2. Negative 2 plus 1 is negative 1. So again, that means either this thing is 0 or this thing is 0. So x minus 2 equals 0, or x plus 1 equals 0. Subtract 2. X is negative 2. Subtract 1. X equals negative 1. Then I need to make sure that they work. So go back to my original equation. Put in the negative 2. So negative 2 plus 2 equals negative 2. Negative 2 plus 2 is 0. Square root of 0 is 0. That does not work. So this is not an answer. That would be an extraneous solution. It doesn't work. So try the negative 1. Negative 1 plus 2 equals negative 1. Alright, so if I could do negative 1 plus 2, I'm going to get 1. And over here I had negative 1. Square root of 1 technically is positive or negative 1. Alright, hang on a second. Let's go back for a minute. Hopefully some of you realized that's not done correctly. My fault. Sorry. Let's fix it. This was minus 2, so you need to add 2. That will make it cancel. Get x equals 2. Then we can plug it in. 2 plus 2 equals 2. 2 plus 2 is 4. Square root of 4 is 2. And that works. Sorry. So this is an answer. If I do this one, technically this is positive or negative, but according to the way your book is saying it, they're always going to come out positive. So they're saying it does not work. So this is not an answer. Number 13. We have r plus the square root of 2 minus r equals 2. Got to get this radical by itself, so I want to get rid of the r, so subtract r. So square root of 2 minus r equals 2 minus r. I'm going to square both sides because I have the radical isolated, so then I need to square it. That will give me 2 minus r over here. Over here, if you know the shortcut, you can use it. Otherwise, just write it out again and do FOIL. So first would give me 4. Outside is negative 2r. Inside is negative 2r. So that's negative 4r. Last, negative r times negative r is positive r squared. Alright, I've got r squareds, r's, and numbers. I need everything on one side. So usually you want to bring everything wherever the r squared is. So I'm going to subtract 2 and add r to both sides. Those will cancel. 0 equals, and I'm going to rewrite this in the right order. So r squared, negative 4 and positive 1r would be negative 3r. Positive 4 and negative 2 would be positive 2. Again, now I need to factor r. Obviously, I need a negative and a negative to get a negative in the middle, and a positive here. So it's got to be negative 2 and negative 1. So that means either r minus 2 equals 0, or r minus 1 equals 0. Add 2. R equals 2. Add 1. R equals 1. Now I need to check both of those answers. So put them back into the original, way up here. So 2 plus the square root of 2 minus 2 equals 2. 2 minus 2 is 0, so that's 0. 2 does equal 2. So far that one works. Plug in the next one. So 1 plus square root of 2 minus 1 equals 2. That's 1. 2 minus 1 is 1. Square root of 1 is 1. 1 plus 1 is 2. So that works also. So this one works too. Okay, so both of my answers work that time. I'm going to clear the page. And the last one we're going to do is number 17. Square root of 2y squared minus 64 equals y. Okay, radical's already isolated, so I'm going to square it. Square both sides. So I get 2y squared minus 64 equals y squared. I want to get everything on one side, so I'm going to subtract y squared. Oops, that's 2 minus 1, so I do get 1y squared. So y squared minus 64 equals 0. Again, you need all those shortcuts we learned earlier. This is something squared minus something squared. So you should remember that it's just going to be y minus 8 times y plus 8 equals 0. Okay, so you take square root of both of them, put a minus sign and a plus sign. So either y minus 8 equals 0, or y plus 8 equals 0. So either y equals 8, or y equals negative 8. Plug them way back into the beginning. So I'm going to have the square root of 2 times 8 squared minus 64 equals 8. 8 squared is 64 times 2 is 128. So 128 minus 64, which is 64, and that's 8. So that one does work. So 8's a possible answer. And then we plug in negative 8, so 2 times negative 8 squared minus 64 equals 8. Negative 8 squared is 64. 64 times 2 is 128. Should it be ending up with the exact same thing? Oops, sorry, almost the same thing. Maybe there's something wrong. This was negative 8. Sorry, that's negative 8 over here. Which means then 8 does not equal negative 8, so this does not work. And that is the end of the video for section 11.3.